Hello guys, hope you guys are doing well. My name is Oche. So today I just want to do like a very quick introduction into machine learning algorithms. Linear regression is the simplest and also the most fundamental machine learning algorithm. It's a way to find kind of like a straight line relationship between two variables. Um let's suppose maybe, for example, let's say maybe you're running a business, right? You're running a small business selling t-shirts. And then you notice that on certain days, as the temperature increases, you make more t-shirt sales, right? So now you want to be able to predict how many t-shirts you will sell based on the temperature. So you kind of have like a feature and then you also have a target, right? So you have like an independent variable, which is the temperature. So as the temperature increases, you have more sales, right? So now linear regression will help you answer the question, okay, if it is a certain temperature tomorrow, how many t-shirts am I going to sell? Without further ado, let's just go into some coding to be able to implement this algorithm. All right. So first of all, you want to import some of the libraries that you'll be using. So I'll be using pandas. You can also use NumPy, but I want to use pandas to create a data frame which we'll be using, right? So I also want to do some visualization. So plot my plot. All right. And then you also want to import the model we'll be using, which is the linear regression model, right? All right. So now we're also going to create like a data frame of from using sample data, right? So we'll create a data frame, let's say PD, and using the method data frame, we'll create kind of like a dictionary, right, of key value pairs of the features, right? So we first of all define the feature, right? So the independent variable, which is the feature that we're going to be using to make the prediction, is temperature. And then we can set it to, let's say, maybe a list of dummy temperatures, right? So let's say maybe 10 degrees Celsius, 20 degrees Celsius, 30, 40, and 50. And then as we mentioned earlier, as the temperature increases, you have twice as much sales, right? So if the temperature is at 10, now we have another variable called the sales variable, right? So we are going to create a target, which is sales. So sales will set sales to let's say 20 because it's twice as much. 40, 60, 80, and what 100, right? So now let's see what our data set looks like. Um, yeah, I think I'm missing something. Okay, let me do this right here. Sorry, you want to put this right here. All right, so let's be able to view how our data set looks like right now. So as you can see, we have the featured, which is temperature, and then we also have the target, which is sales, right? So now we will have to set the feature to be temperature. We also have to set the target to be sales so we can be able to make our prediction, right? So now you want to initialize this variable and we'll set it to let's say then set it to temperature. Temperature. All right. So the reason why we're using double braces is because we are trying to we're trying to return a two-dimensional array because regression models require that it has a shape of a column and also a row. That's why it has to be two-dimensional as a data frame rather than as a series, which is one-dimensional. All right. So let me just write that as a comment. So we're using double braces because psy do I spell psychic? Psychic learn expense. uh, two-dimensional array or matrix, right? All right. So the target is not going to be a two-dimensional array simply because that is your output, right? And you're only returning just a single value, right? Which is cells. All right. So we set that as cells. And now let's run this. Okay, great. So now if we want to see like a visualization of how this looks like, especially with our new data set, right? You can simply use matplotlib to visualize it. So we call in plt dot and then we'll pass in the argument of variables which x and y. Then let's say maybe we set like the points to a color blue. And then we don't really need labels. So let's just leave it at that. And then let's set our X label, right? So our X label is basically the name you want to call the feature on your graph, right? So let's say X label is definitely temperature. Then move this out of the way. Then is our t-shirts sales, huh? All right, let's just give it a title of temperature versus t-shirts sales, and then all right, so this is just a visualization of what is actually happening. So you can see this is a linear model, right? So you can see this is a straight line represented by y is equals to mx plus b. So this is telling you at this point, this is the price. At this point, this is the number of t-shirt sales, right? All right, so now we also want to train our model. This is actually the most important part. So we have to train our model so we can make predictions, right? So now you initialize the linear regression model, right? And then you call the fit method. The fit method is what you use for training, right? And then you pass in the arguments of the X feature and the Y feature, which is the feature and then the target, the independent variable, and then the dependent variable. All right. So yeah, so basically we've been able to train the model. Now the next step would be to make predictions using this model that we just trained, right? All right, now here comes the very interesting part. So now that we're done training our model, now we want to be able to make predictions, right? We want to be able to make predictions based on our trained model, right? So let's say we want to make a prediction of how many t-shirt sales we're going to get if the temperature is at 70 degrees Celsius. I know that's not practical in real life because I don't think anybody will survive under that temperature, but let's see what we'll get. Sales prediction, you initialize that and then you set it to model.predict. So you call the predict method. This is what's used to make predictions, right? And then you let's give it a value. So let's give it 70, right? So 70 is what we want to use to make predictions, right? So this is the input feature, which is 70 degrees Celsius. Now we want to make a prediction to know how much sales we would make if it's at 70, right? All right, so let's see. Okay, it's saying that it does not have, okay. So what this means is we need to define the feature names and might also need to change this into a data frame, right? So data frame. All right. And you should be able to, you should be able to take out the errors. So you change this to a data frame and then you set columns to temperature, temperature. All right, so that error is gone. And now it wasn't really an error. It can actually still work like that, but it's just to make sure that, everything is following conventions. Yeah. So we need to print the result of our prediction, right? We want to be able to know what we just did, right? So to print the result of our prediction, we just say, we call it an F string, right? And the number of t-shirt sales is so let's make sure is 470 degrees, right? I made any mistake? Uh-oh. Okay, so we also need to take into account because this is an array, right? So we only want to call in the first index, right, which is 140. So we need to take this into account as well. So that's if indexing, the first index is always represented by 0, right? So you want to make sure it's like that. Yeah, so now it's working well. But now if we also want to represent it as a whole number rather than as a decimal, we can just call this, we can use this 0. So this will round it up to 0 decimal places, making it a whole number, if you understand. Right. So the number of t-shirt sales is 140 for 70 degrees. So that makes a lot of sense. Now let's say we want to visualize this as well. All we just have to do is just copy what we did above, right? Copy this. And then we paste it below. But the difference is we want to be able to represent the plot, right? So PLT, you pass in that first argument, which is the feature, and then the target, which is the predicted variable, right? So, and then we'll set it to red. Let's use red. And then what else? Yeah, the label. So this will be the regression line. And then we also use legend because I just want you to see the label of the regression line, right? All right, so let's see if this works. Okay, linear regression object has no, oh, sorry, predicted, my bad. All right, so you can see we have this right now. So this is our final prediction. You can see it's a straight line, but to be honest, this is just a very simple implementation of linear regression. Most times when you have a very complex data set, you will see more points than this. So this is actually like the best fit line that shows our prediction, right? But then in complex data sets, maybe like for real estate or something else, where you want to use a linear regression model, you will see more points, data points scattered around this. So what the model does, it just finds the best fit, right? So this is just a very simple and basic implementation of linear regression. So most times your data set won't always show a very clear linear relationship, but by using this, you'll be able to extrapolate from your data set and be able to make good predictions. Yeah, but for data sets like housing predictions, real estate, and those are data sets that have underlying linear relationships. So linear regression models will work well, even for stock price prediction and all that. So yeah, let me know what you guys think in the comments. This was just a very quick run through. I know there's a lot of concepts I didn't cover, like some of the libraries I used. This is just a very simple implementation of linear regression. And thank you guys so much for sticking to the end. And yeah, I'll appreciate any feedback. Thank you.